So there are two types of events. Either events can be dependent or independent. If they are dependent, then conditional probability comes into the picture. If they are independent events, right? If they are independent events, in that case, B has no effect on A. So probability of A by B will be normally equal to. Okay, there was a definition in class 11th, by the way. So there are two major portions of probability which we're going to study. This is divided into two parts. One part is related to PNC problems, permutation and combination problems. Right? So a lot of questions in probability will be based on how well do you understand permutation and combinations, right? Because there will be a lot of formula involved for permutation and combination in probability. And the other part is set theory, in which you will have to apply the concepts of sets, which you have studied in class 11, to probability. So set theory and probability goes hand in hand, right? Now, what we are doing here is we are telling you a formula from set theory that probability of A intersection B, that is probability of happening of A and B together, because intersection means common, or in logical terms, intersection means and is basically multiplication. So probability of A intersection B is basically tells you that probability of happening of A and B together, that in this case, there will be A will also be happening as well as B will also be happening. So in case of independent events, PA intersection B is equal to PA into PB. For two events, if this is happening, the probability of A intersection B, probability of A and probability of B being happening together is PA into PB. In that case, you can say that the events are independent. Right? So probability of A slash B, or probability of A by B, or probability of event A when B has already happened, depends whether the events are independent or dependent. If the events are independent, then they must satisfy this condition. And if they are dependent, they will not satisfy this condition. Right? So hence, how can we apply this formula? Probability of A by B. This is probability of A intersection B divided by probability of B. So let's say I want to write probability of X when Y has already happened. So I can write this as probability of X intersection Y, probability of both of their intersection divided by probability of Y. Now we know what are dependent and independent events, and we also know the conditional probability. This is conditional probability, right? Conditional probability says what is the probability of an event happening after certain event has already happened, right? So A by B is, and this can be defined as probability of A intersection B divided by probability of B. Now, in case of independent events, see, if the events are independent, it only means that this condition, whatever condition you have applied, and the condition is that B event, in this case, the condition is B event has already happened, right? So in this case, your condition should not have any effect on the probability. If the events are independent, right? Why are you calling them independent events? Because they do not depend on each other. So if you want to find out probability of A, B has no role in it. So it means that probability of A intersection B can be written as probability of A. If this is happening, in that case, the events are independent, right? Because B has no effect on it. Probability of A when B has happened or probability of A independently is equal. So B has no effect on it. It means that. And if you apply this formula to this part, If the events are independent, in that case, this should be defined as probability of A intersection B divided by probability of B. Just a minute, guys. Yes. So probability of A intersection, A by B can be defined as with the formula of conditional probability as P A intersection B divided by PB. Now, if A and B are independent, it means that you can write this as PA into PB. PA intersection B can be written as this divided by PB. So PB cancels out. This is equal to PA. Right? So probability of A by B is equals to PA, which should be the case if the events are independent. Right? So hence, conditional probability, it basically tells you what is the effect of an event on the probability of another. If the events are independent, it has no effect. If the events are dependent, in that case, this will be the formula which will be using. This is the formula. So this is theoretical part. Now let's understand it with some questions as well. How is this going to apply? Guys, please come on page number 536. Page number 536, example 6. So it is given that a die is thrown twice, right? And the sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? So a die is thrown twice. Let's start with the information which is given. Die is thrown twice. So if die is thrown twice, can you tell me the sample space? Number of elements in sample space. Do you know what sample space is? Just let me know. Have you studied these terms before? Sample space, number of elements in sample space. Sakina, Naziha, can you guys tell me about the number of elements in sample space here?
So with the conditional probability or without the conditional probability?
Does it depend? Does it matter that we are applying conditional probability or not on sample space?
No, sir.
So tell me the sample space of this event. This experiment.
It's 1 1 1 2 1 3 2.
Yes.
1 4 1 5 1.
Exactly. So sample space basically tells you all the possible outcomes. When we talk about sample space, we are talking about all the possible outcomes, right? And if you're talking, if you're writing number of elements in sample space, so sample space is basically a set, right? With the set which represents all the outputs, all the possible outputs. So if a die is thrown twice, the possible outputs are 36, right? Hence the number of elements in sample space should be 36, which will be 1 2 1 1 1 1 2, similarly up to 1 6, then 2 1 2 2, up to 2 6, 3 1 3 3, or 3 2 rather, 3 6, 4 1 4 6, 5 1 5 6, similarly 6 1 to 6 6. These will be your 36 events, and sample space is the set of all these elements. So number of elements in sample space is 36. Now it is given that the sum of the numbers appearing is observed to be 6. That you have thrown the die, right? You've thrown the die and you've thrown it twice. Now you know whatever numbers were on these two dice, their sum is 6. Right? What is the conditional probability that the number 4 has appeared at least once? So first of all, can someone tell me what do we need to do in the question? Do you understand the question? And whatever you do, whatever the information you can provide, just let me know. I just want to understand what is your basic understanding with the chapter. So please interact. Nothing to worry about. I just want to know what did you learn in the first place, or from where should I start? Yeah.
The event should have at least one die containing number 4, and
Okay.
addition should be 6.
6, right? So that when we talk about sample space, right? In conditional probability, the sample space changes, right? I mean, we have to check the sample space for the condition. So if I say dice thrown twice, tell me the sample space, we were talking about all the possible outcomes of that dice, right? When we apply the condition, after that, what is the sample space? Okay, what is the condition applied? Yeah.
The sample
4
space.
4 1, Nazia.
Or either one of the dice should have number 4 in it.
Okay. So what are the possible outcomes for this? Just tell me those outcomes. Okay, 4 1 4 2. So if the number is 4 1, okay, no. What is the condition applied here? Tell me this. Is this the condition that a number 4 should be there, or is this the condition that the sum is 6?
Sum is 6.
Yeah. See, what is the condition? That has already happened, right? We don't know that the dice contains 4 or not. We have to find the probability of it, right? But we do know that the sum is observed as 6. So whatever statement has already happened, that is your condition. After which you have to observe the probability of some event. In this case, the someone has already observed that the sum is 6. So they are telling you that the sum is 6. Now we have total 36 outcomes, but some of the outcomes will have sum as 6. Now tell me which of the outcomes will have sum as 6?
5 1 1 5
Yes.
2 4
2 4, correct?
4
Correct.
2
4
4
2.
2
Yes.
3 3
3 3. Will there be some other element as well? No, we don't have any other element whose sum is 6, right? So after the condition that the condition in this case is sum is observed to be 6. This has already happened. So after that, the sample space changes. So in conditional probability, When the events are dependent, what happens is your sample space change, right? So it is dependent on it that the sum is observed to be 6 and 5, 1, then 4, 2, then 3, 3, then 2, 4, and then 5, 1. Sorry, 1, 5. These are the 5 possible outcomes which can happen, right? So let's say you can call this event as B. Sum is observed to be 6. And then what do you need? You need the probability. You need the probability. Probability, right? That at least one of the event or one of the dice, right? Rather at least one of the throw. So let's just write at least one of the throw is 4. And let's call this event as A. Right? So what is this event? That at least one of the throw is 4. So can you tell me all the elements inside A?
4
1,
1
4.
1, 4, yeah.
4 1
4, 1, correct.
4 2
Correct.
4 3
Up to?
up to 4 6
Correct. And
2 4
2, 4.
3
Similarly
4
up to 6, 4.
6 4.
Yeah. So how many events, I mean, how many elements are these? From 4, 1 to 4, 6, and then from 1, 4 to 6, 4.
It's
11
11.
elements.
11 elements, right? So because 4, 4 is repeating itself. Hence, total number of elements are 11. Now, either we can see this condition like this, just however we are seeing it. So this is event A and this is event B. We have defined both the events. We have defined one event which represents our condition, and the condition was sum is observed to be 6. And we represent one event as the event of which we need to find the probability. So we define two events. First is sum is observed to be 6. In this case, we got 5 elements. And the second event is at least one of the throw is 4, because that's what we need to find the probability of. And when at least one of the event is 4, there are total 11 elements, right? Now we need to know probability of A by B. That when the sum is 6, what is the probability? What is the probability that one of the throw will be 4? So when the sum is 6, there are two possible elements in which one of the throw is 4. Obviously, both throw can't be 4. In that case, sum will be 8, right? So there are two possible elements only, which does also represents A intersection B. If you take A and B and find out the common elements, there will be two common elements only, 4 2 and 2 4. So if we write this as probability of A intersection B divided by probability of B, or we can also write this as number of elements in A intersection B divided by number of elements in B. So number of elements in A intersection B is 2, 4 2 and 2 4, and number of elements in B is 5. Hence there is a 40% chance, 2 by 5 probability, basically 40% chance. If you calculate it, it would be 0.4. If you multiply it with 100, you'll get 40, right? So there is a 40% chance that if you observe that the two dice has some 6, then at least one of them will contain 4. Now let's just once, let's figure out this question with the logic. Okay. So the logic is, what we have seen is, we know all the elements: 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5. Right. Let me use another color to show you these elements, which basically represents our condition. Right? Oh, no. Yeah. So the events, we have been told that the sum is observed to be 6. When the sum is 6, I'm just highlighting these elements in which the sum is 6. Sorry, this is not the element with me. Yeah, sum is 6, 2, 4, right? 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1, right? These are 5 elements. These are 5 elements which represent the condition, which has already happened. The condition is that the sum is 6. If the sum is 6, we know that there are only 5 possible elements. We know that there are only 5 possible elements. Either it has to be 1, 5, 2, 4, 3, 3, 4, 2, and 5. Out of which there are 2 elements which contains 4. One is 2, 4 and the other is 4, 2. We need to find out the probability of getting 4 on at least one dice. Getting 4 on at least one dice if the sum is 6. Hence, I am also forming another color just to highlight these 2 elements. So this 2, 4, 4, 2 are the 2 required elements out of the 5 elements which we have in the sample space. So the conditional probability is, what does it do? Like naturally, when we talk about conditional probability, what is it doing? What is conditional probability if we figure it out? So conditional probability will first of all shorten your experiment. You will be given one experiment. If the condition is applied, the experiment will be small. I mean, you will have to find out one event that has already happened, which will significantly reduce your sample space. As happened in this case, die was thrown twice, the sample space was 36, but the condition was given that the sum is 6. When the sum is 6, there are only 5 possible elements which can happen now. So conditional probability, first of all, will reduce your sample space, right? And from this reduced sample space, you need to find out the required number of, required number of favorable events. Out of this reduced sample space. So this is what conditional probability represents. Basically, to tell you the probability of an event which has happened or which will happen after certain event has already been happened. Now let's apply this concept on some other questions, some more questions as well, because this was a comparatively very small sample space, because we only got like 36 elements. Okay, tell me some more formally as well. Can I remove this? I have something to ask.
Yes, sir.
Okay, so let me first remind you with these basic formulas. What is the probability of A union B?
Probability of A plus probability of B minus probability of A intersection B.
Good. What is the probability of this? Probability of A intersection B complement. Okay, let's first start with this. What is the probability of P A intersection B whole complement? Okay, so we can write it as 1 minus 3. Do you know this probability of A complement? What is probability of A complement? This is 1 minus probability of A, right? Because probability of happening of some event plus probability of not happening of that event has to be 1. Sum of both of these events, right? Probability of happening something or probability of not happening something. The sum of both of these events should be 1, right? Either event will happen or not. So if you find out the sum of this probability of happening of A plus probability of A complement is not A. It represents not A. So it can be written as 1 minus P. Similarly, probability of A intersection B whole complement can either be written as this 1 minus probability of A intersection B, or by using De Morgan's law. Do you know De Morgan's law? Can someone tell me the expression for De Morgan's? Can we distribute this complement? Okay, no worries. Just give me a minute. Okay, it's okay. So let's first understand set theory before going to this part. So this is basically a set, right? Contained in a universal set. Universal set is basically a universe. So this is set theory, very simple theory, right? And we need to derive some of the formulae. Now, and we will do it by using these examples only. I mean, this is the perfect example which we are going through right now. So these are, we have two sets, A and B. Set can be represented as a circle in Venn diagram. This is known as Venn diagram. So we have two Venn diagrams of set A and set B, and another Venn diagram for universal set. So universal set is basically universe, which contains everything, right? So we have this whole area under A, this whole area under B, and this whole area under universal set, right? Now, if I say what is probability, if I say what is A complement, so this is A, right? This space, just a minute. Let me use some different colors to show you this. This space is A, right? This whole circle. So if this space is A, in obvious choice, this whole space is A complement, which does not contain A. Anything in the universe other than A is A complement, because A complement just represents not A, right? So this is A complement, and this is A complement. Similarly, this is B complement and B, right? Another circle, and the portion outside the circle is B complement. So we have A complement, we have B complement. Can you guys tell me what is A intersection B? If you want to use
A intersection B is the center region.
Yeah, the center region,
Common for
basically
both.
the common region between A and B, na? This
Yes,
is A
sir.
intersection B, right? And if you talk about A union B, what is the portion that represents A union B?
Both A and B without.
I mean, you mean this section and this section, right?
Yes, sir.
Right. So this is this plus this blue portion as well. This is A union B. A union B is either A or B. So any portion which is either in A or in B or in both will be considered in A union B. Right. So let's derive this formula. If I want to find out A union B, you know the reason A union B. Right. Now this can be written as probability of A, that this whole portion, plus probability of B, this whole portion as well. But while doing so, you have considered this blue portion twice, once in A and once in B. So you'll have to subtract this portion from the formula. PA plus PB, that is whole portion of A, whole portion of B. But you have to only write a portion one time, and you have taken this portion, blue portion, twice. That is why you're reducing it one time. Probability of A intersection. Now here, let's understand these things. If I write probability of A intersection B complement, what does that mean? It only means that probability of A, that A should happen and B shouldn't. A should happen and B shouldn't. So can you tell me the portion? What is the common portion between probability of A? Guys, I'm not. What I'm doing is I'm just giving these some of the reference. So this is A, which only represents this portion. This is B, which represents the common portion. This is C, which represents B portion. So what you can call A portion is small a, small, or rather I should write as, my bad, just a minute. I should write these portions as first. This is second, this is third, and this is fourth. So I can call first portion as only A, because this is the portion which only represents A and not B. Total A will represent some of the portion of B as well. But if I talk about first portion, that only represents A. So first is only A. Second can be known as A and B both. Second portion represents A and B both. Now, can you tell me what is third portion? How can you define third portion? Define with a statement like this: only A and B, only B. What is this third portion?
Only B.
Only B. Because third only contains B. And what is fourth portion? Does it contain A?
No,
Does it contain B?
no.
Can we call it neither A nor B?
Yes, sir.
Either we can call it the remaining portion of universal set, or in terms of A and B, you can define it as neither A nor B. Now understand, what does that mean? Only A means that we does not want B, we only want A, right? We do not want B, we only want A, right? Just a minute, everyone. Yes. So only A means that you do not want B, you only want A. So what you can do is you can write it as A intersection B complement. Whenever you want sum and do not want sum, always use intersection. So A intersection B complement basically represents A but not B, which means only A but not B. Now A and B both can be represented as A intersection B. That we want A. In the first case, we want A but not B. In the second case, we want A and B both. So A intersection B. Can you tell me what is the third portion? How can you represent it in the form of probability, in the form of set? Only B. The focus is only on two sets, A and B. How can you define only B in terms of A and B?
Probability of not A. in
Not A,
intersection.
which can be written as A complement, right? But we also want B. If we write P A complement, it only
Intersection.
means that, yeah,
Intersection.
intersection with,
BB.
correct. So P A complement intersection with B means that we do not want A but want B. Can you write this neither A nor B? Not A, not B. We do not want A.
Probability of A complement intersection B complement.
Correct. Very good. So there are four portions involved, right? There are four portions involved in two-set theory. This is known as two-set theory. The theory of two sets. Theory of two sets. And theory of two sets involve four portions. One is only A, one is A and B, one is only B, and the last one is neither A nor B. Now the question is, how can we find them? So probability of A, probability of B, and probability of, you will be given 3 out of these 4 things. You'll be given 3 out of these 4 things in most of the cases. And you'll have to find one. So you just need to know what is the right formula. You'll be given, always given, if there are n elements involved, you'll be given n minus 1 things, and you'll just have to know what is the right formula to use here. What are the things that are known to us? How can we define them in the form of probability? And what is the right formula? So if you talk about probability of A intersection B complement, it means that we want to find out the probability of only A. Now, can you figure out from this picture Venn diagram? This portion is 1, right? This is first portion. If we write probability of A intersection B complement, this is first portion. Can you figure out in terms of this, in terms of the components given in this formula, in these four components, can you define this A intersection B complement? This is portion 1. So you will be given PA, PB, PA union B, or PA intersection B. Let's suppose you have these 4 things. So how would you find out this? Let's say you are given this probability of A, right? So this whole circle is known to us. We just want to find out this portion first. We do not want second portion. But we also know second portion because second portion is PA intersection B. So I can write it as PA minus PA intersection B. Is it correct? From the whole circle, I have subtracted the second part. Whole circle represents A, and the second part represents A intersection B. Both will be given. So this can be represented as PA minus PA intersection B. This is clearly visible. from the diagram itself. Now, on the basis of this, can you tell me this? By the way, probability of universal set is 1. Let's say this is 1. This is basically your sample space. Can you find out this? Probability of A complement intersection B based on the same approach. We want only B, not the whole B. Whole B also contain A. We do not want A. We want only B.
Probability of B minus probability of A intersection B.
Correct. So probability of whole B minus the portion which is common with A. On the same basis, can you define this formula, last one? Guys, just note this, okay? This is important, theory of two sets, because all the formula of sets will be directly used as probability in the form probability as well. Probability of A, neither A nor B. A complement intersection B complement. Basically, we need fourth portion. We know the whole portion is 1. The universal set is 1. Okay, tell me in the form of portions, what is this portion? A union B. A union B is which portions does A union B contain?
1 and 3, but not 2.
Why, Nazia? Not 2, why? A union B means A or B, either A or B. A intersection B is A and B both, right? If we have both the events present, it is basically fulfilling our condition, na? A union B. A union B says either you should have A or should have B, or you can have both as well. So A union B is basically first plus second plus third. A union B does contain A and B. A union B is basically all the portion which is either in A or in B. But we have some portion which is present in both. It's good. I mean, we are fulfilling our condition. No worries. You understand this?
Yes, sir.
Okay. So A union B is 1 plus 2 plus 3. If you want to find out this portion fourth, we can basically subtract 1 minus probability of A union B. This whole portion is 1. Probability of universal set is 1. Universal set is all the universe. So all the universe will happen every time. If you take any point out of this universe, that is in the universe. That is probability of universal set is 1. So if you subtract this A union B, basically first plus second plus third portion from 1, you will get this, which is written as sorry, I'm writing it up. So this is nothing but probability of A union B whole complement. 1 minus this probability. So I just told you that probability of A plus probability of A complement is 1. The probability of happening of some event plus probability of not happening of that event is 1. So we have written probability of, we can write this on A union B as well. If we take probability of A union B plus probability of whole complement A union B, this should be 1. And from this, if you take probability of A, sorry, not this. If you take probability of A union B to right hand side, it will become probability of whole complement A union B is equals to 1 minus probability of A union B, which I have just written in. So this is known as De Morgan's law. What does De Morgan's law says? If you have whole complement on some events, right? On some expression of events, then you can distribute it. You can distribute it on them separately, but you have to change the sign. You have to change the sign. So if you write this, so this is De Morgan's law. De Morgan's law. Again, if you have whole complement on some events, you can distribute it. So you can give it to A as well as to B, but you have to change the sign. So you got intersection in the first expression. So you'll have to change it to union. This is De Morgan's law. Right? This is basically theory of two sets. So event A, can you tell me the portions under event A? Portions under event A. I'll ask you some questions now. I'll understand your understanding of this concept. So just tell me the portions. What are the portions in event A? It's okay, you can give the wrong answer. Event A is this whole circle. What are the portions that event A contains? This whole circle.
Portions 1 and 2.
Portions 1 and 2, right? What are the events or portions under A complement?
Portion 3 and 4.
3 plus 4. What is the portion under B complement?
1 and 4.
1 plus 4. And portion in A, in B?
3 and 2.
Can you tell me the portion under this? A complement intersection B complement. Intersection means common. So you have to find the common portion between A complement and B complement. You know
2.
what does it? Why 2? A complement contains 3 and 4. No? Second.
Yes, sir.
And B complement contains 1 and 4. So you have to find out the common between them.
4.
4. Right? And what is the portion in this? You know A union B is? Okay. Okay, let's understand it from here. So do this. First, tell me the portion between A union B. You know A union B, right? Now A is 1 and 2. Okay. B is 2 and 3. Right? A is 1 and 2, B is 2 and 3. So if I write A union B, I have to write the whole expression. I have to write the whole portion. So A contains 1 and 2. So 1 plus 2. Now B contains 2 and 3, but we have already written 2. So we won't repeat it. We will just add 3 into it. That is how we write union. If a portion is repeating, we do not repeat it. We just add the remaining portion. Right? So let's say I want to write A complement, right? Union B. A complement, this 3 plus 4, union B. So if I will write this, first A complement, so A complement contains 3 plus 4. Now I'll go to B. B contains 2 and 3, but I have already written 3 here, right? See, I have already written 3 here. So I won't repeat 3, but I will add the remaining portion, which is 2. So can you guys tell me this now? A complement union B complement. What does it contain? A complement union B complement. In sets, we do not repeat any portion. What is A complement union B complement, guys? A complement contains 3 plus 4, right? So first of all, 3 plus 4 will have to come. Now we'll reach to B complement because the union is applied. Union says that take all the portions which is in A complement and B complement. When we reach to B complement, it contains 1 and 4, but 4 has been already written. So we'll just add 1 to it. Guys, are you understanding how to write union?
Yes, sir.
What does union represent? Nazia and Fatima?
Yes, sir.
Okay. Now you can also compare these formulae, right? See, this is probability of A complement intersection B complement. A complement intersection B complement. This is A complement intersection B complement, basically fourth one, right? Basically fourth one. Now, if you talk about A union B whole complement, let's understand what is this. A union B whole complement. So basically, first of all, you have to find out A union B, and then you will not take that portion. So A union B is 1, 2, 3, but we are taking complement of it. So basically, we are talking about fourth. And you can understand these two portions are equal because A complement intersection B complement also represents fourth, while A union B whole complement also represents fourth. Similarly, if you take this portion, so this is A complement union B complement. This is the portion A complement union B complement. Now let's understand LHS of it as well. LHS is A intersection B whole complement. A intersection B whole complement. So this whole complement basically means that first find A intersection B, which is 2, and then do not take 2. Take all the portions other than 2, which is 1, 3, and 4 again. Find out A intersection B and take the whole complement. A intersection B is 2, and if we take the complement of 2, that means 1 plus 3 plus 4. So you can understand all of these formulae using a Venn diagram. Maybe you do not remember the formula, but just remember this logic. Some of these things will be given to you. Understand all the portions. If you are given a question, you can apply yourself whole of this set theory. Right? Let's understand 2, 3 more questions on it. Then we'll proceed to another type of question. Come on page number 539. Page number 539. Right? And let's take not page 539, page 538. Take question number 6. Not question number 6. Let's take first question number 1. Let's start with question number 1 only. Yeah. Can I remove this? If someone is writing, just raise your hand. So let's start with first question. We are given two events, given that E and F are events such that P is equals to 0.6. Probability of E happening of E is given. P is 0.6. PF is 0.3. PF is 0.3. And PE intersection F is given as 0.2. This is given as 0.2. We need to find out the probability of E in when F has already happened and probability of F when E has already happened. We know the formula for conditional probability. This is conditional probability, right? Because we want to find out the probability of event E when F has already happened. So we can use E intersection F divided by the probability of F, which is written in the denominator. We know all of these things. This is 0.2. This is 0.3. So we got 2 by 3. Similarly, if you want to find out PF when E has already happened, this will be PF intersection E divided by PE. We got all the things. This is 2 by 6, which is 1 by 3. So this is a question which is given just to tell you how to use the formula. And what are the things? What is the information that can be given? Right. This is a very basic question. No, not second. Let's start with third. You have to apply this formula yourself this time. PA 0.8, PB 0.5, and PA when or PB when A has already happened is given to you. That is conditional probability is given, which is 0.4. You need to find first of all probability of A intersection B. Fatima, can you tell me which formula should we use? Probability of B when A has happened is given to you. Okay, Naziha.
Probability of B given A can be written as probability of A intersection B divided by probability of B. B. Yes, sorry.
A or B?
A.
What
Sorry.
should be
Yes,
written?
A.
Yeah, PA.
A.
So always you can remember this like this, that the denominator comes in the denominator. So if probability of B given A is given, in that case, probability of A will be in the denominator. And we have been given certain things about from this. So how can I use this information in the given formula?
So 0.4 is equal to probability of A intersection B divided by 0.5. So probability of A intersection B is equal to 0.4. Yes,
Yeah.
0.8.
Yeah. So probability of
0.4 probability of A intersection B is 0.4 multiplied by 0.8.
which is 0.32. So we'll be given some of the information. We'll have to find out one from the given information. one variable each time. Now we have to find out probability of A intersection B. Sakina, how can we do this?
Probability of A intersection B by probability of B.
Correct. Fatima, do we know this information? Can we find out this?
Yes.
So what is the value of probability of A? Sorry, I have written union here. My bad. So what is the value of probability of A intersection B?
0.32.
Correct. Divided by?
0.5.
So this should be 32 by 50, which can be further reduced to 16 by 25. Now C part. We have to find out probability of A union B. How can we solve this, Fatima? Probability of A union B? This will be solved by theory of two sets. We have written the formula, probability of A union B. What is the formula? I've just written the formula. Check that formula and tell me.
P of A plus P of B minus P of A intersection.
A intersection. Do we have these? The required information? Do we have this?
Yes.
What is that?
0.8 plus 0.5 minus 0.32.
Yeah. This will come out as 0.98. Right. So based on these formula, 4-5 formula from set theory and one formula from conditional probability, we'll be given these questions. We have to use them and find out the given. I mean, this is a 1 or 2 marker question only. Not a very big question. This can be dealt with the formula. Okay, so can you solve fourth? Fatafat solve fourth and fifth, guys. Then we'll move on to sixth. In fourth, you have been given. Okay, so do you know the meaning of this expression? Can I remove this? If somebody is writing, just raise your hand. Cool. So I just want to understand, do you know this expression? If there are 2 equals to applied. What is the meaning of this? What did you understand by this expression?
Probability of B is 5 by 13.
Okay.
And
good.
probability of A is 5 by 13 by 2. That is
Correct.
5 by 26.
Yes. So there are 2 implications. First is PB is equals to 5 by 13 because there's a constant involved. So we can find out the 2 variables. One variable is PB. PB is 5 by 13. And then second equation is twice of PA is also equal to 5 by 13. From which you can get probability of A as 5 upon 26. Right. So there are 2 implications of this. And then we have been given probability of A when B has happened, which is 2 by 5. I have to find probability of A union B. You know everything required. And if you don't know something, you can find out. You have been given the sufficient information to find out probability of A union B. Find it out.
We need to find P of A intersection B.
Can we find that out with the given information? We do. Yes, we do need to find out this. We have this. We need to find out this. But how will we find this, Fatima? Okay, what is the use of this? The use of this information is to find out probability of A intersection B. Because probability of A given B is written as probability of A intersection B divided by probability of B. Use the formula for conditional probability. And this value is given as 2 by 5. So probability of A intersection B is 2 by 5 into probability of B. Probability of B is 5 by 30. Hence, this value is 2 by 30. So you know everything.
Five by 26 plus 5 by 13 minus 2 by 30.
Yes, and what's the answer after solving this? Multiply this by 2 by 2 so that the denominator becomes same. So this is 6 now.
11 by 26.
Yes. So fast calculation, if you can make the denominator same, you can directly add the numerator or subtract the numerator. The answer is 11 by 26. Guys, solve fifth as well. Guys, by the way, while you are doing this, I just wanted to ask you one question: that are you guys free on Thursday as well? We can have a extra class on Thursday also, if you guys are free.
Sir, at what time?
8:30 to 10:30. I mean the same time, Fatima, or we can also increase half an hour.
It's the evening time.
Yes, this time, same time.
Yes,
At the
sir.
same time, the
Okay.
class is happening. Okay. Cool. Then we can have the class on the same timing. From Indian perspective, this is 8:30 to 10:30. So we have a class on Thursday on the same timing, which is for today. For fifth, guys, PA is given. PB is also given, I guess. Yes, 5 by 11. PA union B is also given. Tell me the answer for any part if you have solved. Or as soon as you solve any part, just tell me the answer.
Probability of A intersection B is 4 by 11.
Correct.
Probability of A given B is 4 by 5.
Yes.
And B given A is 2 by 3.
Correct. Sakina and Fatima, do you guys also get the same answer?
Yes, sir.
Yes, sir.
Good. Now we have to solve sixth. After that, we'll directly go to 10th, 12th, 13th, 14th, 15th, these questions. But before that, first solve this question number 6. Now, I just want to understand the concept of set, I mean, the theory of 3 sets. So a coin is tossed 3 times, right? We need to find out probability of E given F in all the cases, right? And for the first cases, E is defined as head on third toes. And F is defined as heads on first 2 toes. What is the condition? Just tell me this. Okay. I don't want the answers, not just the answers. I also want to understand what you guys been learning. So just tell me the condition which has already happened here. A coin is tossed 3 times, right? There's a coin which is tossed 3 times. There must be a sample space according to this, right? And we'll have these 2 events out of the sample space. First event is E, which is head on third toss, that the third toss contain head. And there's an event F, which is heads on first 2 tosses. We need to find out probability of E intersection F. Oh, sorry, probability of E given F. According to this expression, can you tell me what is the event that has already happened in the case A? Is it head on third toss or is it heads on first 2 tosses? What is the event that has happened?
Head on third toes.
Head on third toss. Okay, this has already happened. No, guys, no. You need to understand this statement. That how to, I mean, what is this PE given F represents? Or what is the significance of this expression? What is the physical interpretation of this expression? PE given F only represents the probability of event E, probability of this event when this has happened. So we need to find out this, find this when this happened. When this happened. So in this case, F has already happened. In every case, whatever the event is here, like if you ask me PA given B, what is the event that has happened here? B. This is the event that has already happened. This is the event that has already happened. So whatever is your event that has already happened will govern the whole question now. That is the main condition now. Like in this case, F has already happened. It means that this has already happened. That heads on first two tosses. We do have heads on first two tosses. We have it. So can you tell me the sample space of F?
HHH,
Correct.
HHT,
HHT. Will there be more element? No, Fatima, there will be no other element. No, right?
yes sir.
Because heads on first two tosses is already confirmed. So we have HH. We can only change the third event, which will possibly
Yes.
result in two outcomes, either head or tail. Right?
Yes sir.
So either
Yes.
HHH or HHT. Now, in this, out of this, we have to understand the condition of E, which says head on third toss. Head on third toss. So if we define this, yeah. So what is the answer? Can you tell me the answer?
HHH,
No. The final answer. What is the, I mean, probability of E given F? What is the answer of this? You know everything now. Just connect the dots. I mean, every one of you knows this. What should be the answer of PE given F in this case? F is your total sample space. That is I mean, you only have two elements in that. Either it is HHH or it is HHT. Just identify how many cases are true for event E. For event E, there's only one case true. So your favorable outcome is 1 and your total outcomes were 2. So the answer should be 1 by 2. Probability is always, what is probability? Favorable upon total. So just understand the concept by logic as well. You can always define this using this set theory also, but just understand the logic because this is very easy. If you understand the question, this is a very easy question. It is saying that we have heads on first two tosses. We want to understand that what is the probability of head on third toss when we have head on first two tosses. So we are saying that there are two possible elements. If there are heads on first two tosses, so either third toss should contain head or it should contain tail, in which we want to find out head on third toss, hence the probability should be 1 by 2. No?
yes sir.
I mean, this is the physical interpretation of the question. Obviously, you can solve it using maths, all the maths, set theory and all. But the basic interpretation is this. That there are heads on first two tosses. You want to understand if there are heads on first two tosses, what is the probability that there will be head on third toss as well? Or it can also be given as that E event is tail on third toss. So we want to understand if there are heads on first two tosses, what is the probability that there will be tail on third toss, which is again 1 by 2. Right?
Yes sir.
So event E, now if we write the whole event E, if we write the whole event E, that is head on third toss, we do not give consideration to F right now. We just want to identify what is event E. What does event E contain? That is, in how many cases can we have head on third toss? So can you tell me all those elements in which there is head on third toss?
HHH,
HHH,
HTH,
HTH, good.
THH,
THH,
TTH,
TTH.
yes.
Yeah. So there are 4 elements in E. There are 2 elements in F. But if you want to find out PE intersection F, I'm sorry, PE given F, that we need to apply this formula. Or rather this formula. Instead of P, we can also use N, number of elements, either probability or number of elements. You can use anything. Number of elements in the E intersection F is basically the common elements between them, which is 1. HHH, and the number of elements in F is 2. The answer must be 1 by 2. Guys, can you solve second and third? Try them. Just try to write the whole event just like this. And then also tell E intersection F, which is HHH. Now you have given the required information. You can use it. Can I remove this?
Yes, sir.
At least is minimum 2 hits, and at most is maximum 2 hits. So what is the condition that has already happened here?
Almost 2 hits.
Yes, at most 2 hits. Did you find out the answer?
It is 3 by 7.
3 by 7. Is it so?
So at most 2 hits.
Yes, at most 2 hits is 7. Definitely. But
Then
at
at
most,
least 2 hits is 3.
yes, 3. At least 2 hits is 3. No. At least 2 hits is not 3, I guess. No? I think it should be 4,
Yes,
no?
sir, yes, sir. It's wrong.
It should be 4. No? At least 2 heads. So we have either H, 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 T, right? Then again H, T, H.
And THH.
My bad. Yes. Then THH. Then these are 4, and then TTH, THT, HTT, then TTT. So if you're talking about at least 2 heads, these are 4 possible, right? So E contains this. This is E, and at most 2 heads is these 7. This is F, right? The answer is 3 by 7. Correct.
Yes, sir.
E by F should be, these 3 are common. This is 3 by 7. What is the answer for C? Just tell me directly. I just want you to understand the concept. Nothing else. E, at most 2 tails. What is the portion E? These are 8 events. Total sample space is 8. What is E? At most 2 tails. Here's what's the answer.
Six by 7.
Yes, sir.
Sorry,
6 by
Fatima.
7.
Sorry. First,
6 by 7.
6 by 7. Correct. What about Nazia and Sakina?
Yes, sir. Good.
Got it, sir.
Now let's come to question number 9.
Sir, can I
Yes.
leave now? I do have to prepare for a test tomorrow.
Okay, Nazia. What's the which subject is the test from?
It's from chemistry, sir.
Okay, okay. All the best.
Thank you, sir.
Sir, I would also be leaving.
Okay.
Thank you, sir.
Yeah. Fatima, let's come to question number 9.
Yes, sir.
Not 9th, 10th. A black and a red dice are rolled. You have to solve. Just a minute. Yeah, you have to solve first part only. 10th first part. Try it and ask me your doubts if you have any. Okay.
Yes, sir. Sir,
Yes,
sir, is the answer 2 by 6?
correct. Very good. Just solve the last question. Last question from this exercise, question number 12.
Question number 15.
12th.
Okay.
Rather solve question number 15 only. Yeah. Question number 12 you'll have to do yourself.
Okay.
Question number 15 for now.
Sir, can you explain me the question?
Yes. Just a minute. So it is given, consider the experiment of throwing a die. If a multiple of 3 comes up, throw the die again. And if any other number comes, toss a coin. Okay, so if a multiple of 3 comes up, first of all, tell me if we throw a die, what are the possible outcomes?
Sorry, sir.
If we throw a dice, what are the possible outcomes?
1, 2, 3, 4, 5, 6.
Correct. But it is given that if you obtain a multiple of 3. Now, can you tell me what is a multiple of 3? Any number who is in the table of 3. So it is 3, 6, 9, 12. These are all
6,
multiple of
9.
3.
Yes. Yes.
Yeah. So if we talk about 1 to 6, there are 2 numbers which are multiple of 3. 3 and 6. तो बोला ये जा रहा है कि अगर 3 and 6 आता है, right? यानी कि 3 का मल्टीपल आता है, थ्रो द डाई अगेन. आपको डाई दोबारा थ्रो करना है. एंड इफ एनी अदर नंबर कम्स, अगर 1, 2, 4, 5 आता है, तो आपको एक कॉइन टॉस करना है, राइट? तो
Yes,
कुछ
sir.
ऐसा एक इवेंट बन गया. इफ 3 and 6, sorry, just a minute. Yes, 3 or 6, तो थ्रो द डाई अगेन, यानी कि फिर से कोई नंबर मिलेगा आपको 1 से लेके 6 तक. और अगर 1, 2, 4 और 5 आता है, थ्रो अ कॉइन. यानी कि आपको
Yes.
फिर हेड या टेल में से कुछ मिलेगा. अब हमें इस बात की प्रोबेबिलिटी बतानी है. फाइंड द कंडीशनल प्रोबेबिलिटी ऑफ द इवेंट. द कॉइन शोज अ टेल. द कॉइन शोज अ टेल. वन इवेंट इज कॉइन शोज अ टेल. तो एक इवेंट बना ले इसको ए, लेट्स से कॉइन शोज अ टेल. और एक इवेंट बना ले बी, इसको एटलीस्ट वन डाई shows a 3. At least one die shows a 3. तो देख, मैं तेरे को सैंपल स्पेस बना के दिखाता हूं. अगर 3 आया तो तुझे फिर से डाई थ्रो करनी है. तो यानी कि फिर से 3-1 हो सकता है, 3-2 हो सकता है, 3-3 हो सकता है, 3-4 हो सकता है, और यहां से लेके 3-6 तक कुछ भी हो सकता है, राइट?
Yes,
फिर
sir.
वैसे ही 6-1, 6-2, 6-6 कुछ भी हो सकता है. मान ले 3 और 6 आया तो फिर से कॉइन थ्रो करनी पड़ेगी, बट मान ले 3 और 1 आया, है ना, थ्रोइंग डाइस, या ठीक है, अगर मान ले 3 और 1 आया, 3 और 1 आया तो 1 आते ही फिर से तेरे को कॉइन थ्रो करना पड़ेगा। पहले चल ये समझते हैं, ये वाला समझते हैं। तो अगर 1 आया तो या तू कॉइन थ्रो करेगी, या तो आएगा हेड या तो आएगा टेल, यानी कि 1, H 1, T, यहां पे ये खत्म हो
Yes.
जाएगा। वैसे ही 2H 2T, वैसे ही 4H 4T, वैसे ही 5H 5T। समझ आई बात?
Yes, sir.
अब देख, अगर 3 आया तो 3 आया तो तुझे दोबारा डाई थ्रो करनी है। अगर 3 आया और दोबारा डाई थ्रो करी और 1 आया तो 1 आते ही फिर से तेरे को एक कॉइन थ्रो करना है, क्योंकि ये रूल तो लग ही रहा है। तो 3 1H और 3 1T। क्या ये बात समझ आई?
Yes, sir. Yes.
और ऐसे ही अब 3 2H 3 2T। 3 3 के बाद क्या होगा? थ्री थ्री के बाद फिर से देख डाई थ्रो होगी, तो फिर से यही पूरा प्रोसेस चलता जाएगा। क्वेश्चन समझ आया तेरे को?
Yes, sir. Yes, sir.
टफ होगा थोड़ा, बट ट्राई कर।
So we will write as A will be the coin shows a tail, and B at least one die show a 3.
Fatima, actually, what is happening here is the sample space which I have just made is incorrect. And why is that happening? Let's understand. So, just
Yes.
is the answer 0 for this question? Just check once.
Sorry, sir.
Is the answer 0, Fatima, given for this question? Is the answer to this question 0? Check
Yes,
it
sir.
once. Okay. Yeah.
Yes, sir, it's 0.
Okay. Let's understand the question once more. Okay, so this is 3 or 6. If 3 or 6 comes, we have to throw a die. And if we will be throwing a die, in that case, either 3-1, 3-2, 3-6, or 6-1, 6-2, up to 6-6. Right? And if 1, 2, 4, or 5, then we have to throw a coin, toss a coin. In that case, the answer would be 1 tail, 1 head, 2 tail, 2 head, 4 tail, 4 head, and similarly 5 tail, 5 head. Right? So this should be the sample space, Fatima. Now we have defined a event which represents what? A and B were coin shows a tail, right?
A is the coin shows a tail,
Yes.
and B is at least one die shows a 3. At least one die shows a 3.
Okay, so if coin shows a tail, what are the favorable events to this? You can check. This is your whole sample space. If coin shows a tail, then 1, t, right?
Yes, sir. 2, T.
3t
3T,
and 4t.
4T, 5T.
Yes. Not 3t. It should be 5t, no?
Yes, sir.
We don't have 3t. And if at least one die shows 3, it means that 3-1 से लेके 3-6 and 6-3.
Yes, sir.
Now they clearly देख सकते हैं दोनों में कुछ भी कॉमन नहीं है. A intersection B is 5. अगर 3 आएगा तो टेल आ ही नहीं पाएगा क्योंकि 3 आएगा तो फिर से आपको एक डाई थ्रो करनी है. तो
Yes,
इसका
sir.
मतलब नंबर ऑफ एलिमेंट इन A इंटरसेक्शन B वो होंगे 0. तो अब हमें निकालना है P A by B. Okay. प्रोबेबिलिटी कोइन शोज अ टेल गिवन दैट एटलीस्ट वन डाई शोज 3, जो क्या होगा प्रोबेबिलिटी या नंबर ऑफ एलिमेंट्स इन ए इंटरसेक्शन बी डिवाइडेड बाय नंबर ऑफ एलिमेंट्स इन बी। ये है 0, बी वाले हैं 7, तो आंसर 0।